All right, lesson 5.3, solving systems of linear equations by elimination. You guys have already learned substitution, correct? Answer me. Yes. The biggest difference with substitution and elimination, substitution, you're solving for an equation all to one variable, correct? Like x or y by itself. Doesn't matter which one, right? Yeah. Elimination, you're trying to find a variable that has the same coefficient for both, except for one of them is positive and one of them is negative. Okay, and then that's how we're going to eliminate a variable and solve for a different variable. I'll give you just a minute to finish writing this. Okay, so we're going to look at example 1 and solve this system of linear equations by elimination. Some of you, this will be your favorite method of solving systems of linear equations. Some of you will still prefer substitution. After this lesson, you can choose which one you want to do, but for this lesson, you have to do elimination, okay? All right, so looking at this system, we're going to look at the coefficients. The same numbers in front of x, and we're looking for the coefficient to be the same. However, one of these is not positive and one is not negative. So let's look at the y. Is one of these positive and negative? Yes. So we're going to easily be able to eliminate y. So this time you're going to line these up just like you see here to solve. Kind of like old school arithmetic. Line them up like such. And then we are going to pause because I have a phone call. So we've lined them up. So now we're just going to add the coefficients vertically. So we have a 3x plus a 3x gives you 6x. The y's are going to cancel because you have a positive 2 minus 2. So that gives you a 0, which just means the y is gone. So then we go 4 minus 4, which is
0.
Also 0. So you write the 0. Can I solve for x now?
Yeah.
Absolutely. You divide by 6 and get x equals 0.
That's crazy.
Okay, it's not always easier.
When the numbers aren't the same.
Well, no, then you just manipulate it so they're the same. We'll get there. But yes, in this moment, this is faster. So then you take the 0 and you plug it in for x on either one of these two equations. It doesn't matter which one. So that gets rid of your x, and we can solve for y. So then I divide by 2. 4 divided by 2 is
2.
So now we have our solution, 0, 2. Great, right?
Yes.
Yeah. Now elimination, when it's simple, is faster. But when they get complicated, it can get real complicated. All right, any questions on how we did this? All right, so then you need to go do, example 2. Here we go. So everybody got that one? Can I move on to the next example?
Yeah.
Excellent.
Wait, I have a question.
Okay.
The next example is going to be like long. Will it fit in like a piece of paper?
It will be longer. Because you notice here, it doesn't immediately match up. Right? There's no coefficients the same. So this is where you have to manipulate one of the equations. So we're looking for a coefficient that has the opposite sign, so positive and negative, same coefficient, right? These have the same sign. These do have the opposite signs. We'll see what they say, but I would change the y value to be the same. How do you think we're going to change the y value to be the same as this 6? Multiply this whole top equation by 2. Now, could I change this to be the same if I wanted to? Yeah, I could multiply the bottom equation by -5. But then I'm going to get a bunch of weird negatives too. So you can actually pick which coefficient you want to match up. You just multiply the correct thing. This is where it can get complicated. So I'm going to see what they chose. Haha. So we're going to do the top equation by 2. So what is -10 times 2?
Wait, but it's
Oh, they're doing the bottom equation. So they want to multiply this by -2 on the bottom so we can get the x values the same. That's fine. We'll do it that way. I would have done this because it's already opposite signs. And so it's literally just multiplied by 2 and you're done. but it's fine. So negative 2 times negative 5 gives you positive 10. Negative 6 times negative 2 gives you positive 12. And then 23 times negative 2 gives you a negative 46. So now you can see my x values, the coefficients are opposite, same coefficient. So I can eliminate the x value, correct? So you line them up and add.
Okay, so I understand how to get complicated if one of them is not the multiple.
Correct. That's when substitution's easier. All right, so what's 3 plus 12?
15.
And then 1 minus 46.
Negative 45.
And then we divide by 15, which is beautiful, easy math. Y equals negative 3.
And then you have to put that.
Now we take that negative 3. Here's the other catch. You do not put this negative 3 into the manipulated equation. So I always just put it in whatever equation I did not manipulate to avoid issues. Because you can technically put it in the original equation, but I always forget. So whatever equation I did not manipulate, that's where I plug in my negative 3.
In this case, the top one.
Correct. So I plug it in for y. Negative 3 times 3 is negative 9. Move it over, so you're going to add 9. Let's see, is that where they... Oh, that's where they did put it.
I wrote that down. Don't put y.
Nope, they put it in the second one. Yeah, I don't.
So x equals negative 1.
Solve it and you get down to x equals negative 1. Whichever equation you put it in.
It worked.
Negative
I
1,
had
negative
enough space.
Wait, what did y equal
Yay.
again? Oh, negative.
Negative 3. So then, yes, don't forget to write your solution as a coordinate. Ordered pair, thank you. I think coordinate because I think graphing, which is funny because I actually hate graphing. Ordered pair.
Oh my.
And then if it were to be graphed, that's how you do it. On a graph. This is an actual graphing calculator. That's what they look like. All right. Any questions on how we did that? Ask them. I have no problems answering them. All right. I'm going to guess you're going to do one now. 3. All right. Numbers 1 through 3. Do it. Has everybody got this written in their journals? Awesome.
Is this gonna take like a lot of space or no?
I have no idea.
It's one problem.
A business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Is that cakes? Cakes. All right, we're serving cakes. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. Location B receives 2 large vans and 3 small vans for a total cost of $160,000. What is the cost of each van? So we have 2 equations that we need to build off of this.
5x plus 2y equals 235,000.
Yep.
And 2x plus 3y equals
160,000.
160.
Oh, it was right in my face. I could just.
You did great.
Oh,
So the first equation, 5x plus 2y equals 235. And 2x plus 3y equals 160.
None of these multiply good.
Yeah, they do.
Do they?
They'll be fine. Well, I would multiply by the smallest. So if we want... Oh, we're going to do a double.
Oh.
Yep, we're going to do double. All right.
The what? Oh, to get the...
So to get the coefficients the same, we're going to have to multiply both equations.
This is giving us the vibe of like.
And you guys were all like, I like elimination better.
Making the numerator the
I
same.
think I
Correct.
No.
Substitution
Maybe
is
the
better.
denominator
All right.
is the same.
So, we're going to multiply both equations. One of them will multiply by a negative number, and the other one by a positive number to get the coefficients the same.
the same number?
Each equation will be different. So we're going to multiply equation 1 times negative 3. So we're trying to eliminate the y because it's going to become a
Oh, so
6.
we're doing- okay, yeah, that makes
And then we're going to multiply the second equation by 2. So 5x plus 2y equals 235. Multiply the whole thing times negative 3.
Wait, then how would you put in the coefficient? Like, how would you put in y?
We'll get there. When we
You'll
get
see.
That's.
So what's 5 times negative 3?
Negative 15.
Yep. 2 times -3,
-6.
and then -3 times 235.
-705.
Way to read the screen. You're doing a great job.
Oh, I was reading.
Giving you a hard time. Good job. So the first equation is done. Now the second equation, we want the y coefficient to be a +6 because we just made this one a -6. So we're going to multiply that whole equation by 2.
4x
Correct?
plus 6y
Correct.
equals
A number.
320,000.
320,000.
Very good. 320,000.
Okay.
So now do we have coefficient that is the opposite sign and same coefficient?
Yes.
Correct. The y coefficient. So line them up and add. What's -15 plus 4?
-11.
And the y is gone? Eliminated? Eliminated. And then -705 minus or plus 320 is?
385,000.
Negative. Do not forget the negative.
Oh, yeah.
That's what I said.
I heard it. 100%. Now we divide by what?
-11.
-11. So makes it positive, which is good because we're not dealing in negative vans. We have positive vans.
35,000.
35,000. So that's for x. So that's the x value. Now you plug that x value into one of the original equations. It does not matter which one.
What would the
I'm gonna do
original?
it in the.
I would do it by the second one because you're only multiplying times 2. And they're going to do it in the first one, of course.
I.
Let's see if you get the same answer. Do it in the second one. That's fine.
Okay. After I already erased that.
Why? Don't erase. Just do it. I'm
Just
not.
do
I'm not that picky.
Still writing the equation.
Yeah. Take your time.
Okay.
What'd you give for y?
30,000.
So that means the. Which one was the x value? The large van or the small van?
Large.
X value is the large van. The y value is the small van. So the large van costs
Oh, that makes sense.
35,000.
Costs
a little more, and the small van costs 30,000.
Oh, 'cause they're-
So in a word problem, you need to answer in words. You guys know that, right? So now, do you have to write a whole sentence? No. You could say large van, 35,000 with a $sign. Small van, 30,000 with a $sign, and I would accept that.
I always forget. Does the dollar sign go in front? Or
In front, always in front. If it's after, it's
It does?
Asia.
Oh, that's.
Well, and Europe too. I think they put their money sign at the end. We put the cent sign at the end. So if you say 50 cents, the little C with the line, that goes at the end. We're weird Americans. It's just the way it is.
Why is it an
always
S
wanna be different.
with line through it?
Oh.
Yeah,
I
you're gonna
like
have to
this
look that up.
monitoring progress.
I know.
All right. Monitoring progress number 4,
What?
and that's it. 4 things today. Easy lesson.
Yo, take a look at the monitoring progress.
You'll be fine.
Yeah.
I'm scared.
It's exactly what we just did. Oh my word.
Are you done already?
Because it's the same.
It's the same exact problem that we did in the
Oh.
Did they change anything?
Nope.